Welcome, everybody. Uh, we will get started around 3 to 5 past the hour, so you have a couple minutes to get yourself something to drink or something to eat, relax, have fun. Welcome, everybody. We'll get started. Today's webinar is with Zontal, and the title is Creating a Fair Data Layer as Your Foundation for Data Preservation and Integration. Zontal has been a big player in this space for many years now. They've honed their skills in their trade, and they're a very sought after organization for medium to large size biopharmas. So we're honored to be able to work with them here. The rules of engagement is the first topic we'll talk about in our agenda. We'll just do a brief industry perspective to orient everybody. And then Christoph will give his talk from Zontal, and then we'll spend the last 20 minutes or so answering questions. So please feel free to submit those. You can put those in the chat box or the Q&A box, either or, and then we'll address them in the Q&A session. Now, importantly, if you have to leave early, you can put them in there and they will get answered, and you can come back and watch the recording at your leisure to see how they were answered, or just reach out to Christoph. So we're in this space. We're not only marketers and helping spread the word for a lot of our really good clients out there, but we also do a lot of consulting as well. And so we're knee deep in all this work as well. And I think we try to be as applicable as possible and as relevant as possible, so that we're speaking your language as a scientist, as an informatician, as an IT person, etc. So the first slide is, what is fair? Findable, accessible, interoperable, and reusable. And I don't know how many people on this call have realized, but AI is in the word fair as well. And is that a coincidence? I think not. But really, it's a change in thinking around uh, data, process, instrumentation, all as an asset, not just data. Data is a big part of it, but a lot of times the instrumentation and the processes produce the data. So having that fair is very important as well, and we've dealt with this in the industry. Like all projects, programs, it's a journey. You've got to set your milestones. You've got to figure out how you're going to get from point A to point Z or whatever, along the journey where you set your milestones, EFG. But think about it as that. It's not a eat the elephant all at one sitting, and it's not a big bang. It's a way of thinking. It's a culture change. And you really need to set your culture first to get people to treat data as an asset. Get a scientific data strategy in place, the governance, the stewardship, the rules, the standards, all of these things are critically important for that culture change, and the change management to get there. We just had a webinar yesterday on change management. It's critical in today's complex life sciences world. Big organizations, lots of people, lots of things happening, and lots of complex science and constantly changing. So just a reminder to people, what is scientific data? So I liken this to data is just another form of currency. It's another form of money. A lot of money is spent with a lot of bright people, a lot of hardworking people, and a lot of experimentation to produce this data. So you're converting money ultimately, along with human intuition, a lot of spend in lab automation, et cetera, to produce this data. You better guard it. You better treat it like it's an asset. You should treat it like it's the money that you're making and in your investments that you're making, the interest you're earning on your money in the bank. You're organized, you know where it's at, you know where your account's at, all of that. Unfortunately, a lot of scientists don't want to hear this, but this is reality. You really need to take care of this data because it's not only the primary experiment that it's produced for, but in today's world with AI, and it's here to stay, it's the reuse, it's the secondary, the tertiary, the quaternary use of that data over and over again in machine learning and in AI. And as many of you on this call have already started to see the benefits of these tools in your workflows. And if you haven't, trust me, you will over the next year or two, because it is going to be there to help you make better decisions. And the only way to make those really, really good decisions is model quality data. That's this data. It's fair. It's been contextualized. You're using data standards. You're trying to speak similar languages, and bam, you're now able to use AI where, and this has happened to me, you're in a drug discovery project and you don't know where to go and you're out of data and you need to make key decisions. Well, if you can leverage data that's already been created in other projects and programs and things to make a better decision on direction, that's fantastic. And that's where the world is going. So if you don't, you unfortunately end up in this dark data, trash data world, and it's not fair. 50 to 80% of your organization's data, scientific data, can't find it, can't access it, you can't use it, and you're never going to reuse it. So it's just sitting there wasting energy and space. So you really want to do what I'm telling you here. I'm pleading with you. And Xontal is one of these companies where they're building these fair data environments for their clients. And trust me, the benefits are going to be 1 + 1 = 4. So I'm going to introduce Christoph Gansler. He is the director of pre-sales and marketing at Xontal. Dr. Gansler holds a doctorate in molecular biology from the University of Heidelberg and contributed to the development of the first HPV vaccine during his time at the German Cancer Center in Heidelberg. During his career outside of academia, Christoph served as senior consultant and pre-sales manager at TIBCO Spotfire and as the senior principal product marketing manager for biology at PerkinElmer Informatics. Currently, Christoph brings his expertise to Xontal as the director of pre-sales and product marketing. And Christoph, I want to hand it off to you now.
Thank you for the nice introduction. And I need to share my screen, I guess. Always interesting.
As soon as I see it.
No, you don't see it yet.
Not yet.
Is it? Should come any second.
There you go.
There it is. So let me
All
quickly
right.
introduce Sontal again. This is a second webinar in a multi-part series that we're doing together with John and the Visioneers team. And we are very happy to discuss today the digital preservation aspect of data, because that is the underlying the foundation for doing anything fair with data that John just described. And of course, it is the foundation for integration between different systems and processes that you have in your lab, but also beyond your own labs, with your collaborators, and even inside your company with stakeholders that might need access to your data in a completely different format. And with that, I get a warning. I will go off camera. I'm sorry for that. There seems to be something with my internet connection. So our understanding of the industry in Zontal, and this is always the same, that really every R&D organization, of course, have identified the need to have a data strategy. And that's good. Not everybody is at the same level there. But with Sontal, we can guarantee that we are integrating the data out of your lab and out of your systems with the automation aspect in mind. So you can actually send and receive data from ELNs and to ELNs, and from instruments and to instruments. All of this is currently a digitalized lab aspect that Sontal can support. And as the guiding principle behind that, we have the fair data layer. And in contrast, what we did before we had the idea of fair, and sometimes we still do that now, we have a point-to-point connection. We have this instrument-centric view of the data in the lab. So we have different connections to this instrument, or to the PC that is connected to this instrument. So we have an ELN that gets data, or sometimes even sends data to the instrument. We have analysis tools that load the data directly from the instrument. And we have data archiving. And data archiving is a good thing. Yeah, don't get me wrong. Data archiving makes sure that the data that is on the instrument is actually secured, and you can always put it back on the instrument if somebody would delete it. This is the first step to the underlying principles that we have, and Sontal is creating this fair data layer because we need not only to preserve the data one-in-one here from the instrument, that's what we do as well. So every data file is saved, but also we are creating the interoperable aspect of this data. So that means we're parsing the data out. We're putting data, we're putting data, or attaching metadata to that data set. And we are creating, out of the parsed data, we're creating a mostly allotrope simple model, ASM, data structure. That means it's an open structure that you can reuse, and it's not a silo, it's not a black box. This is your data that you get from this instrument. The important part is here that it is not only working for this one instrument. It's working for hundreds of different instrument types. And the result of this instrument data that comes out is actually always following the same data model. That means if something breaks, and this is usually when the instrument gets an update, then we can fix it by by fixing the connection to the instrument. The resulting data will always stay the same, so you don't have to fix any other connection to that data later on. And this is what Sontel has been providing for many years to customers, that it creates this fair data layer that is really covering all aspects of FAIR, including the reusability and the interoperability, because the data sets inside Sontel are created to be in a vendor neutral format. And this could be, as I said, as a standard where we're using the allotrope format, but there are exceptions, of course, always to this rule, and Sontel can handle that as well. And you can see here that it is really always a sending and receiving of data and information, not only sending data from the instrument into the data layer, but also retrieving information like a plate map, like a test request from one of the systems here on the upper half of the screen, and then taking this into Sontel, converting it into the format that the instrument needs. And in the case of a plate map, we can actually send the plate map or a sample list to the instrument in the format that the instrument will understand it, and thus making sure that the whole process here, from the planning to the doing and back to the analysis, is automated in one go using the Sontel data platform. So how does that work? And since we are talking today about digital preservation, there's one step that is extremely important. Well, it is to get the data. And it doesn't matter. In this case, we have an instrument. Data can be also coming from an ELN, a LIMS system, or whatever. But in this case, we have an instrument, and we have our data watcher that takes care of bringing all of the raw data, the files and the produced results into Sontel in its raw format. That's the first step. But this is only the archiving part. Now we do much more with it. We are actually extracting metadata or extracting data out of this. Might be in the file name, might be inside the file itself, that you have a sample ID or a batch ID. And then during the processing inside Sontel, before it's even just pushed into the FAIR data layer, Sontel is can reach out to systems that give more information, provide more information on a sample ID or a batch ID. And retrieving these attributes and sticking them as metadata tags onto that data package that we just created. And then, as I said, we're creating this vendor neutral format. We're parsing the data, and this gets stored. And even if there are on the instrument different data types, like we have an Excel formatted file, and we have a document from Word, or we have vendor proprietary formats, we take all of that and store it together. And that means everything is following the same ingestion, and doesn't matter if it's a system or an instrument. We always create this. We always add the metadata. We always create the vendor neutral format, and we always put it into what looks like a normal database to the consumer. So we have our user interface where you can search and have the faceted browsing for all of these metadata tags. And you can actually also access all of the data and the metadata programmatically through systems that have data that do database access or an API. So how does that work? In our case here, I would like to show the example of a flow cytometry experiment where we're actually storing all of these data sets, all of the files that come from the experiment. And this is the end result. This is a viewer inside Zontal that shows me the results of that flow cytometry experiment. And let me quickly show you how that's working. So we have the faceted browsing here. That means I can see here are the different metadata tags that were attached to this. And via that, I can, and this information package profile will quickly talk about later. These are all different. You can think of it as different instruments or instrument groups, and they are providing us with these information packages. Every line here is one of these information packages. And why I'm talking about information package is really clear. We have our attached metadata here that we have as part of this information package. But we also have the raw data files here that are all part of this information package. So these are the data files, and there are some Excel files in here, and we will see other examples later on. But of course, this is even in the case of flow cytometry, we're looking at the analyzed data. But what about the data that this came from? And so you see here, there's a plate map, and while the system is building up here, we can see that this is information coming from the plate map. We have different populations here. So this is something that comes out of other data sets that are also stored in Zontal, and that in this case, this viewer can access based on what I have selected as a user. And if I'm looking at a certain well here, I get this raw data directly displayed, and this is something that's just for the quality control of it. If we're going down here, I can even go into the gating that was done. So this gating is not done in Zontal. This gating is done in the analysis tool, and it's saved into Zontal alongside with the raw data, with the plate map, with everything that is needed to actually have a good example, a good view into my experiment. So all of this is in the back saved and provided back to the user, back to the user interface from Zontal, from inside Zontal, with the logic that comes automatically when we're ingesting all of these data. Because we know that the plate map, because we retrieved it from the planning tool, belongs to the raw data, and the raw data then belongs to the analyzed data. All of these links are possible automatically if Zontal is taking care of retrieving and sending data from one step to the next. So Zontal is aggregating this data automatically, and the really dreadful job of a scientist of manually editing this metadata is taken away because we are automating these steps directly. And in the end, of course, you can then create also your own visualizations on this data that is stored in Zontal. In this case, in the example in the back, there we're not only talking about one result, that we're one experiment, but we're going across all NMR experiments that are in the system. And we can, for example, see which type of instruments these NMRs were run, produced from, who did them and when. So all of these operational questions, you can ask this data set as well, which is the kind of reuse of parts of that data that we would like to see in such a system that underlies all of these processes of the lab. And of course, the data that you can directly retrieve and do your visualizations, here in this case, using Spotfire. So if we put all of this together, that we already have seen that we can search inside Zontal, and that is facilitated through this concept of this information package profile, which is an instrument or an instrument group. And this already collects this information for me. That means I know which users and groups have access to this data, which properties are attached to it, which are the ingestion scripts to get this data into Zontal, which are the workflow rules that this information, this data is embedded in. And there is a sixth, in this case, sixth aspect of this, and this is the retention policy. That means also Zontal takes care of data that is then archived and needs to live on the server for a certain period of time, like 10 years, and then it needs to be reviewed if it stays on the platform or it needs to be deleted. And on the other hand, also you can have, for these retention policies, the possibility of a legal hold, that nobody touches this data, nobody deletes it. We need this for legal affairs. So this is all inside the Zontal platform itself. And coming back to my flow cytometry example, this is how it looks like if you don't have a digitalization of this workflow. And yeah, we can go into all kinds of details on who is accessing what data and where is it backed up and where is it analyzed and where is it shared. And this whole thing, this whole process is in the end a PDF that is in an email. And so losing all the connection to all of the results that were created before. So if I'm on the receiving end of this PDF, I might have the question, well, is this useful? Is this does this solve my my question, my need for my own work? And most of the time, I am stuck at this point and decide I need to redo this experiment because I don't have access to all of the original information that went into this result. And so I'm doing the same thing again. If I can get to the data, and if I actually have, in this case, FlowJo installed, I can do the analysis myself. But this actually can take weeks or even months to get to that. And so the question isn't it quicker to create or recreate this entire experiment myself, which is of course time costly and doesn't need to be. So, and that's the reason why you do experiments yourself again, because this is an example of a PDF that you get. These are triplicates of treated versus untreated. This is the result communication that you get in this PDF in your email. So of course, this doesn't tell you a lot about the experiment itself and about the reasons why this was a positive or a negative outcome. And you have seen this. I just demoed this in Zontal. Here in Zontal, you can then, instead of the black and white PDF, static PDF, you have the possibility here to look up all of the information that went into this example or into this experiment. And of course, you can create much more visualizations here, but the analysis was done before. But this is the good thing. You don't need the FlowJo application for everybody who would like to just see, was the gating done the right way? Can I believe in this result? And what did they test as a background, or what did they test as a negative control? Things like that you can easily get to in the Zontal platform, because the data is there and it's in its original form, and it's parsed out, and it is available even in a viewer. So let me quickly change gears here, because the idea of digital preservation also goes hand in hand with the use case that we have seen at many customers now. And that is archiving, digital preservation of an ELN. And that has a lot of similarity to the digital preservation of a instrument dataset. So Sontal does treat an ELN as it treats any instrument. We are reading data. You see our data watcher again. We're treating the ELN as a data producer. There comes a new experiment. This new experiment is ingested by Sontal, and it might come in a shape of an XML. It might come in shape of a database that we access. Sontal doesn't really care. We're getting all of the data of this experiment into Sontal. And then, in order to make it fair, we are creating this allotrope format again out of the experiment. And I will show you an example of that later. And we're enriching it. We're aligning it, for example, with the Allotrope Foundation ontology. And we can reach out to compound DBs, databases, if we have a chemical experiment, and with reference and master data. So we attach all of this metadata to this experiment so that we can find it again. And we're extracting, of course, all of the data that is inside this experiment and make it available inside Sontal, and of course also inside the database that is in Sontal. This has a couple of use cases for our customers. We have the preservation of a legacy ELN in combination with the current ELN. So we can actually have our users query these ELNs in the same system. They don't have to query one system and then query the other system. They can query both, and since we're ingesting everything, including the attachments, including the audit trails, they can actually be searched at the same time by users. And the users here are not only the scientists. The users could be legal teams or regulatory users, which actually have their own place in their own user role, even in Zonto. And the third thing here is not only the internal ELNs that our customers have, but also in the case of acquiring mergers and acquisitions team are always interested in, of course, getting access to the data of the biotech that they acquired into their own in the hands of their own scientists. And this is of course another good use case for the centralized management of these ELN archives. And then the next thing is also a logical consequence of this. You can actually decommission systems. So if you say that as an ELN or a database that we have created 20 years ago, and it ran until 10 years ago, and then we moved data over into our ELN or LIMS system, but we couldn't put all of the data into that LIMS system or the ELN system. So what do we do with the data that is remaining still in these legacy systems? And we have to keep them up, even though they are completely outdated. They might run even locally on an old Windows server, things like that. They even cost money because we still have to pay license fees for this. And we have still a group of 100 scientists that need access to this data 3 or 4 times a year, so we cannot switch it off. This is a typical use case where we see that our customers are coming to us and say, okay, we would like to ingest this data into Zontal so that it's preserved, it's there with everything that we have in that old database, and then we can finally decommission it. And this is, of course, then available to the normal things that are in Zontal, like the search, like um the just the viewers, or we can even do uh data science on it, which we couldn't do before. And looking at the time, we can say, okay, let's look into one of these ELN examples. So how does that zero loss really look like in Zontal? And this is just a screenshot. Let me quickly jump into my browser here and show you this ELN archive viewer. And you can see there's a lot of different things are ingested here in my demo system. This is one experiment that was run and has many things attached to it. And this viewer is a general viewer for all ELN archives that we are producing. That means it configures itself by just reading the data that is in this allotrope format. And in this case, we have, for example, study results, and I will put this on here already. And this is in the biology domain, we have here growing cells, and we have this in a fermenter, and we have, for example, the concentration and of these cells. Many more things that we can look at, but with a normal 900 shaker, 900 RPM shaker, we have this over the days here. We have these results. So all of this, and it doesn't matter where this data comes from, how this experiment is set up, all of this is stored inside Zontal and represented here. Means if I'm going up here and choose not necessarily the from the agitation the normal results here, I can see, okay, let me find my turbidity here. So another thing that how does my probe look like? How does my fermenter look like? And you see down here, now it loaded the data set for the 1, 2, 4, 7 days in that into that. So all of this data is actually linked, and all of this data is available for review. If you need a report for your attorneys, then this is the way to do it. You can print all of these, and it doesn't matter from which ELN they originated from. Yeah, the report will always look the same as the viewer is looking the same. And of course, and to show that here in this example, I just reached with in this case with Spotfire out to this database, and it's a normal JDBC connection to that database, and I can create this very easily. And I have here my turbidity and my in this case my normal concentration that we've seen before, and of course it's timed out. So that I cannot show it. Now I can. This is a visualization of three different batch conditions and of the same measurement. So I have three different batch conditions in this case, and I'm seeing the same measurement, in this case, the turbidity at the 350, and now it tells me I have to go um, back to my slides here, but this is the way that you can access it, you can preserve it. It's always coming in the same data, in the same way the data is preserved. And since I would like to be able to take some more questions later on, I know that there are questions are lining up. Just a quick view on this instrument, on this archive viewer. With a couple of screenshots. So this is how a completely different kind of experiment, a CombiChem experiment, is also visualized with the same viewer, with the same way of these different steps. So we have the library, we have the products, um, we have the measurements. We have attached PDF files that are visualized directly here because these were measured, and the result is a PDF in this case, and in the old ELN. And so all of this is preserved, and this is the audit trail of the original ELN. And of course, inside Zontal, we have an audit trail of when this was ingested and when this was um, like made available in the system. But of course, the experiment itself, especially if it's an experiment from an old ELN system, we would like to have, or we are depending on sometimes on the audit trail, which is also part of that archive viewer, and all of the attachments here, like the PDFs I have shown. And this is all stored, and this is how I can get to it with like things like Spotfire. This is stored in the database, and this is stored in the allotrope simple model. That means this is a readable file. This is a JSON-like file that all of this information is saved and preserved, digitally preserved for you in the future. And with that, I would like to hand back to John, and I'm sorry that I'll try my video again.
Great job, Christoph. It looks really good. Looks great. We've got some questions. All right, so the first one is, how does Zontal know how to ingest different types of data and from different sources? Do you have to customize ingestion workflows for ELNs versus lab equipment and for different data types, or are there out-of-the-box plugins?
That's a good question, because yes, we have, of course, hundreds of connectors on our webpage. We have a list of all of the instruments that we integrate with and all of the systems, down to like an Empower connection via a third-party tool. So all of these possibilities are there. And yes, for ELNs, we are working with the vendors usually. We have connected to the big ones. So this is you might have seen this was a Cambridge Soft ELN that I showed. We have of course also the Revity Signals Notebook, Benchling, IDBS, whatever is there, we already have. And then it's usually a configuration to make sure that we can access the data and not a new programming.
Okay. If that answers all your questions, you can just it's anonymous, so I can't. So just respond and let us know. I Another question is, did Zontal set out to intently or inadvertently start to create data products from what we saw there, those profiles, those data profiles? Would you consider those, some of these starting to become data products for one of your clients where you can start to wrap, some boundaries around some of this? What are your thoughts there?
Yes, these are for sure data products. The idea of the where Zontal is coming from, the allotrope foundation, was actually to, first of all, to be able to exchange data. And this data is not only data, as we've seen now from instruments, but it is also it going into the experiments, it's going into the methods. So also methods are now part of our universe of data that we collect. And if you put all of this together, yes, it's a data product that we're creating and you can reuse without the need of ever ETLing data again.
Exactly. Yeah, exactly. It's pretty powerful, and you can break it down across domains, across access levels, and I think it could drive massive insight to different groups and departments. So that was really cool to see. Um, from a fair perspective, as you guys get into this work, so we've always said, hey, a data project is anything from a walk in the park to a, oh my God, it's a nightmare, right? Type of scenario. Are you guys running into, have you seen an improvement in data environments over the years with the clients you're working with? Or are you still seeing a lot of struggling to get these fair data environments up to snuff and, and good to go?
There are, I would say there's a need in several, or there was the need in several, uh, yeah, different domains to become more modern. And
Yeah,
that's good. We see that, and that's perfect. We have, of course, vendors that we're working with who are already embracing the allotrope format, or that have something that they could actually export, or have actively APIs that we can use to create to get the data and and to be able to send data into the system. Like it's just a sample list is a very good example of, yes, this has to be integrated and this has to be managed. And yes, we see that people are thinking about that actively. If we're going into more the mechanistic things, like into manufacturing, into scale up, then we see a lot of really restricted because of GXP, um, restricted systems that where we have a hard time even talking to the vendors about getting access to their data. But as soon as they understand that this will be part of the bigger picture for that company, and say this is what leaves that this is what lets us be in this part of this journey, they usually are open to discuss and give us access and make sure that their tools and their instruments are used also in the future for this.
right, right. Okay. So, you talked a little bit about allotrope. Allotrope's made a huge difference to the industry. What about um what about where there's no allotrope support? What if particular vendor or
Yeah.
clients haven't bought on or signed on? And so first of all, how much harder does that make your lives? And second of all, what are you guys doing about it?
So we're not absolutely tied to allotrope. And that means that if there's, for example, an MZML standard, yeah, then we use the MZML because that's the most efficient way to store and preserve that data. So this is a good thing. Yeah, we can have multiple different ways of going about this vendor neutral format. Um, but for now that we have access to these these customers that would like to have an allotrope definition of their data, they can actually go to allotrope and say, okay, like this is what we think the allotrope format should look like. And many times it's us who create an allotrope-like ASM data model that we
Got
can
it.
use, and then we can even over time actually adapt to whatever comes out of allotrope if we are even starting it. And then from scratch, we would create an allotrope-like one, and then we can work with allotrope and usually the customers to drive that into an allotrope standard.
Right. I guess another one, Christoph, would be Sila. You know, a lot of companies have adopted Sila formats and things like
Mhm.
that. Is that another example of where you guys have run into Sila and you've had to work with clients around, you know, those standards, et cetera, as well?
Yes, and we have also companies that even go and say, okay, we'd like to adhere very early on to like the scope of a clinical data set. Even though we're not in the clinical setting, we would like to become more and more the later it gets, the 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 more we would like to be able to have everything under one roof. And so yes, there are standards
Okay.
that we can adhere to.
Okay. So brass tacks, here's the usability question. I've got data, I got to get it in there. I need to bring it in and I need to share it with my colleagues like pronto. We're on a mission critical project.
Yep.
What's that level of effort? If what does somebody have to do to, you know, work with their data at that level?
This is we're talking about very quick turnaround times for the different steps that I have shown, like bringing data in and attaching just a minimal set of metadata. Like you can always get into the file name. So if the file name gives you data, we can already put like an old school SDMS, put the data in and attach a basic set of metadata to it so it's preserved and findable already. This is something that can be extremely quick to turn around. Parsing, sometimes there are as more human readable the files are, the more easy it is to if we don't have a parser yet for it, um, to create one. And many times we have this expertise already at the customers. That's what I find a lot. That people say, "Oh, we have this Python script there. This reads out the data uh, out of these data files, but it's not integrated. We have to run it manually." And I say, "Okay, give me that Python script." Yeah, we put it into our, for example, into our we're working with Airflow in the back as a technology, and we put it into an Airflow DAG and then it's integrated. And whenever data comes from this instrument, it's already parsed.
Super helpful. You know, so keep, you know, I talk about not just fair data, but I talk about processes, instrumentation, automation.
Yep.
Based on everything you said today, that's the reality, right? It's about that whole environment, right? Being fair. Is that is that a fair statement? I mean, that's kind of what I'm asking you. Does that sit well with you when I say that? And it because when I saw your diagrams here in your talk, to me it made perfect sense.
Thank you. Yes, it is. And we needed to overcome. I was sitting in the in the fair data panels 10 years ago and tried to overcome the laziness of scientists. Having been a scientist myself, I know I don't want to put metadata from manually copying from one system to the next. So how can we overcome this? And
Yeah,
this is the horizontal question to this is very simple. It's like, let us connect to all of these steps and make sure that you don't have to manually copy and paste something anymore. We know it, we put it in there. My go-to example is we have a customer that said there is a measurement that a scientist would like to do ad hoc usually. They plan it currently, then they walk to the instrument, create the measurement, and then they take the file, take the plan, and have to like produce literally an Excel file out of it. So our task was planning is still done in the same software, but the scientist can push a button, and when the scientist reaches the instrument, the sample list is that he planned to measure is already in the instrument. By pushing the execute button on the instrument, 2 minutes later, after the measurement is done, this is already at his desk, all of the data together in one nice report that they can use.
right.
So that's the future. And the idea is that this is done for every single workflow in the lab, because that makes it the life easier of the scientists. And it's not, oh, I forgot to put all of this into this shared drive yesterday. Yeah.
Yeah.
So
So, so do you guys do a baseline before you start? Because I have plenty of experiences where, so we had 40-minute processes, data processes, etc. We rebuilt the whole environment. It took less than, it took 20 seconds, and people would complain, oh, that takes too long. And we're like, wait, what are you talking about? It took 40 minutes. We're at 20 seconds. We're at the mercy of your internal environment. We've got it. So that institutional or experience knowledge gets lost, right?
yeah.
And it's very important to capture the baseline. So I hope you guys are getting that, because you're making a huge difference. But the other thing that's hitting me square on the head is the two targets with one stone here. You're not only creating the data environment, but you're preparing for the AI layer that's going to sit on top of this one day, which is ultimately going to be, the
Yes.
bomb.
Yes, and we are already using large language models on, especially on these
Yeah.
archive data, together with the new data. So
Yeah.
when we're talking about ELN, there is of course verbose text in there that scientists typed in, yeah, what they think about that result. And this can be mined, literally mined for information. And large language models are a really good thing that we already have put on top of this on of this data. And I can chat with my ELNs now. So that is something that is definitely already done, and is very important. And then talking about speed is usually not it never comes up again. But yes,
Right.
like
Exactly.
we're going from 3 days to 2 minutes. And then exactly what's up. But this takes too long. It's like it shows it shows the spinning circle for 30 seconds, where it's like, yeah, but it's actually it just saved you 3 days
Yeah,
of work. So this is
exactly.
yes.
So the efficiency gains, just mentioning what you're mentioning and all the things that we've done, you're probably in the 40 to 60% efficiency gain realm when you start to take full advantage of this. Which again, you equate that to FTEs, that's millions and millions of dollars in a large organization a year, just by doing things like this.
Yes. And we have the start of the conversation is many times is, okay, we need to reduce the amount of experiments that are redone because people can just not find the original ones, or
It's
they
crazy.
don't trust in it.
Yeah. Yeah, it's that was going to kind of be my next question, is managing expectations when you're stepping into a project like this with you guys. If and everybody has to be honest with themselves. Like, we know the numbers, but if you're not compliant in the use of your current tools, your ELN, isn't configured, it's not templated, it's not this, it's not that, you're going to have to bear with a company like Zontal working through getting this all working, but also trying to at the same time point out to a client that, hey, your ELN environment is not ideal, and here are the steps you need to take to make it that, so that we can even get better results for you with our Zontal platform. I mean, I
Yes.
can only imagine that's got to be the case in places, because we see it every day.
Yes. Yes, you're right.
Okay. All right. Well, believe it or not, we're right at the top of the hour. I thought you did a great
Hey.
job, Christoph. I think Zontal's doing a great job. This is like um, one of the premier uh, scientific data fair platforms out there today. So there might be a couple others, but you guys are at the pinnacle. And I think you're doing awesome work. And just kind of, you know, I always feel like the better the scientific data, the more efficient, the better quality of life for all beings and everything going on. Misinformation gets reduced dramatically, like you mentioned. Repeating unnecessary experiments, it's crazy. But even the reproducibility of science has suffered. People talk about academia, it's here in industry too, and we really need these tools. and the culture change to make a huge difference in our industry.
Yep.
And you guys are right there at the forefront doing that.
Yep. And yeah, Sontal.io is the website and where you can actually reach us or look at our instruments. So instrument
Okay.
list.
All right. Well, thanks everybody. Have a great rest of your week, and we'll see you in the next Zontal 2015 Visioneers webinar. Take
Perfect.
care. All right,
Take
bye.
care. Bye.